Okay, let's try another one. So I see rate of change, which tells me it's slope. So, and I'm looking at, as I peek through here, I see some t's and y's. So that would tell me that they're talking about dy dt. And it's proportional to y, so that means it's something times y. So again, I want to make sure that I move all my p's and q's. Just kidding. All my t's and y's. So I'll have dy over y. And remember, k is a constant. It's not a variable. So don't let that trick you. Okay, so then I'm ready to integrate. And on the left, I'm going to get natural log of y, absolute value, because I need to make sure y is positive. And on the right, I'm going to get kt. Remember that k is a constant. It could be like 5 or 7. So I'll end up putting a t back on it, and then I'll put my plus c over here. So I'll collect all the c's on that side, because I'm going to want to get y by itself. So I'm going to need a superhero over here. What would you like on his shirt, Taurus? An E! So we'll make everything an exponent, which means those will cancel. And again, I have e to the, oh, I'm noticing a pattern here, a kt plus c, which can be split. Think about, just always go back to this. If I gave you x squared times x to the 7th, you would end up with x to the 2 plus 7. And so this is the same strategy. Same base, I can split, so same base, I can split that base into multiplication between the two of them. And that's all that I'm doing. I notice I have a plus sign, so I can split, give them both the same base, but it does in fact become a multiplication just like it was up here. Okay, so then e to the c, so a constant to a constant is still a constant. So this is all going to turn into kind of crazy in calculus, isn't it? All these letters turn into more letters. Makes me chuckle. And so now I'm going to go back and substitute in my beginning information. Gonna have to take a ride here, guys. Roller coaster! And I have two pieces of information. So first I know that when t is 0, I know y is 2. So that's going to look like this. 2 equals ce to the k times 0. Of course, all of that's going to magically turn into e to the 0, which is 1, and so I get c equals 2. And then I want to figure out what y is. Oops, what happened here? So now I know that y equals 2e to the kt, and I'm still trying to figure out what y is when t is 3. And so I go, okay, so wait, if t is 3, what's y? Oh, I still don't have enough information. I would need to solve for another variable, that being k. So then I go back and I notice, oh, I do have some other information that I haven't used. So I know that when y is 4, t is 2. So let's see what happens in that particular scenario. It's going to look like this. So now it'll be 2k. And then, of course, I'll want to solve for k, which is in the exponent. So I'm going to have to divide both sides by 2. So if I divide both sides by 2, it'll be this. Oops. And then I'll have to use logarithm to get that k down out of the exponent. Now, I could use any base, any log base, but I'd like to use natural log because once I bring down the exponent, this is going to cancel out and I'll be able to